All right, going over polynomials. First off, let everybody sit on the count of 3. Hi, Mr. Watkins, because Mr. Watkins wanted to be here, be a part of this class today. So, on the count of 3, hi, Mr. Watkins, and wave to the camera. 1, 2, 3. Hi, Mr. Watkins. All right. Yesterday we started working with polynomials of degrees, zeros with functions, multiplicity. Questions you have. Hopefully you're working at it. Again, need to discipline yourself. Need to discipline yourself. You got solutions provided for you. You need to work towards the solutions. If you are not disciplining yourself and getting your homework done, it will eventually catch up to you. Okay? Need to continue to work at this. Anything you need me to go to? Yes. Number 7. Calculate the zeros of the polynomial. So we have P of x is equal to 2x cubed plus 6x squared plus minus 4x. We're talking about zeros of the polynomial. We'll see what makes that equal to 0. So we have a polynomial here. It's a trinomial. Before we try to factor down into binomials or use quadratic formula or complete the square, whatever we need to, I would like to see if we can pull out a greatest common factor. Can we pull out a greatest common factor here? What is it, Nick? X. Not only x, what can go with it? 2. A 2. So we have 2x. Then we have x squared plus 3x minus 4 is equal to 0. Okay, we can take a 2x out of each one of the terms. Then we can factor our x squared plus 3x minus 4. We have x and x. We have a negative 4 there, so the sign has to be different. Yeah. 4. Oh, it should be a 2. My bad. So we have a minus 2. Well, if we take a look at this, not factorable. Okay, so we have an issue here because it's not factorable. At this point, you have 2 different means you can go into. You can go completing the square, or you can use your quadratic formula. Okay, whatever works for you. When I have an odd value here, I tend to go into quadratic formula. So we have A equals 1, B is equal to 3, C is equal to negative 2. So quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2a over 2a over 2a over 2a. So we have negative 3 plus or minus 9 plus 8. So we have square root of 17 over 2. Okay, not perfect square, so I can't break it down any further. But we can't forget about this 2x either. 2x could equal the value of 0 here. So x could equal 0, or x is equal our value here. Once again, I tend to go into quadratic formula when the b value is not even. If the b value is even, I would go into your completing of the square. But that's my own personal choice. You make your own personal choice at that point. Other questions? Once again, this is 2 solutions. You have negative 3 plus square root of 17 divided by 2, then negative 3 minus square root of 17 divided by 2. So you get our 3 solutions, which also corresponds to the number of degrees.
Can I have it? I did it yesterday and then I left it in my script binder. Promise I won't do it. Because I gotta do it, dude. No, it's in my script. Promise I ain't doing it.
Okay, today we're going to work with synthetic substitution, synthetic division.
I'm not sure.
First problem here. We have f of x equals 4x to the 4th plus 5x cubed minus 7x squared minus 4x plus 10. I want you to evaluate that function at a value of 3, which means our x value is a value of 3. Our x value is a value of 3. So you're putting in 3 for all of our x's and coming up with a value. And the value we come down to is what, Ava Sweeney? 394. Yes, no, maybe so. Okay, now, as we can see what is happening here, we take our 4, multiply it by 3 4 times, plus 5 added to our 3 3 times, minus 7 times our 3 twice, minus 4 times our value of 3, and then we add 10 to that. Now, before the advent of the calculator here, okay, and being such a nice tool to have at your use, at your disposal, we used to not have calculators. Okay, so we had to do all this mathematics by hand because we couldn't sit there and just clickety-clack it through our calculator and come up with a value. When I was in school, I was lucky to be able to borrow a calculator from somebody around me. Okay, I think my mom and dad had a very basic one at home that I was able to, type some numbers into, and found that it was a lot easier to just do it all in my head. Okay, that's why my mathematics skills increased, because I had to do a lot up here. I didn't have a calculator to be able to multiply out a trig function, decimal, 4 decimal places. I had to do it all by hand. Humans try to find easier ways of doing things. That's just how it is. Why did automobiles get invented? Because people got tired of walking or riding on the horses. Okay? They got tired of it. Their legs got tired. So we want to make life easier on ourselves. That's us humans. That's how we are. Well, this is also true in the mathematical world. So what we turn this into, this type of problem, is something we call synthetic substitution. Well, what's the word synthetic mean? Fake? All right? Yeah?
Not natural.
Not natural? Wow. Nobody else knows any other idea. Fake, not natural, which they're all correct. Synthetic. Man-made.
Yeah.
Okay? Man-made. Synthetic turf. Yeah, synthetic turf. That's man-made turf. We don't have to mow the yard anymore because we have synthetic stuff out there. Well, synthetic substitution is the same idea. What we use with synthetic substitution is we just use our coefficients. We have the value of 4, we have the value of 5, we have the value of -7, the value -4, and the value of 10. Okay, I put them in degree order, 4, 3, 2, 1, 0. And what we put out front here in a little half box is a value that we're going to substitute in, which is the value of 3. Little finger space there because we're going to write in it and we can draw a line. Okay, so you don't want to put the line right underneath these numbers because you're going to write in this. So we give ourselves a little finger space in there. Now, our goal with synthetic division is to accomplish this exact same thing. I want to multiply this value of 4 by 3 4 times, the value of 5 by 3 3 times, and so on. So, going through synthetic substitution, the first thing we do is we just drop down our 4. We drop down our 4. We then do a diagonal multiplication by our value in the box. So we multiply by the value of 3. So we have 4 times 3, we get a value of 12. And then we can add down to give us 17. And then we continue this process throughout. We diagonally multiply by 3, which gives us 51. Then we add down. So we get a value of 44. We diagonally multiply upwards, which gives us 132. Then we add down 128. Then we diagonally multiply upwards, 384. And then we add down.
Whoa.
And what miraculously happens as I pull out my magic wand, Ali Kababa Shishkumba, this 394 that we just have right here ends up being the exact same value.
How does that work?
How does it work? How does he do it?
Magic shows.
Smoke and mirrors.
Smoke and mirrors.
Let's see what has happened here. Why does this work? The value of 4 gets multiplied by 3 1, 2, 3, 4 times. Because this value here is 3 times 4 plus 5. That gives me my 17. Well, that value is 17. I'm multiplying by another 3 here. So now I have 3 times 4, 3 times 3 times 4 plus 5. So I'm multiplying by another 3. Well, this value here has all this embedded into it. Multiply by another 3. Multiply by another 3. So So I'm multiplying by this value of 3 4 times. The value of 5 that we bring down gets multiplied by 3 1, 2, 3 times, just like we set up here. The value of negative 7 gets multiplied by 3 twice, here and here. The value of negative 4 gets multiplied by 3 once. Yep.
You know the perfect descending order of exponents. What would you do?
Put them in order. Put them in order. And if one is missing,
Yeah, that's what I was saying.
what do you think we put in there? 0. Because if we have one missing, if we had x cubed plus x to the first minus 7, okay, that would give me x cubed plus 0x squared plus x minus 7. So I put a 0 in there, so I maintain my degree place order. Very quickly, just over here to the side, run negative 2 through. Run negative 2 through our synthetic substitution. Same polynomial. Once again, the issues we start running into with our calculator is when we substitute those negatives in, sometimes we forget to put our parentheses around the negatives. And you have negative 2 squared comes down to negative 4 for you, where it should come down to a positive 4. Kate Miller, what do you get for negative 2? 14. Yes, no, maybe so? Good with that? Once again, synthetic substitution. And if, there's a great question, what happens when we don't have a place value there? We don't have a square term. You throw in a 0 in your order then. So we would go 1, 0, 1, negative 7. Okay, we just don't say, no, we don't have anything. We put the 0 in. All right, we get to venture back to our fond memories of 5th grade mathematics. Our fond memories of 5th grade mathematics. We don't have a calculator. We want to divide 8,769 by the value of 21. We don't have a calculator. My solutions, I want to write my remainder as a fraction. Write your remainder as a fraction. So I'm taking 21 into 8769, and I want to write my remainder as a fraction. Go ahead. Oh, man. It's amazing. 5th grade mathematics. And we reviewed that also in 6th grade mathematics. Oh, yeah. Is that Mrs. Martin for you guys?
Yeah.
There we go. See, we get to relive your glory days here a little bit.
Glory?
Yeah. I feel like we should have Bruce Springsteen trying to sing a song here. Glory days, glory days. For all you Bruce Springsteen fans. He's an old one. He's an old geezer. He's older than I am. Isn't this fun? Don't know how to use a calculator. Do it without a calculator.
I know, I remember how to do it.
Okay, and once again, the purpose behind this is what I do a lot in all my classes. You should be used to it. I want to take you something back into an area that you hopefully are a little bit more comfortable with. Something that you can utilize to take it forward into when we start dealing with division of polynomials. So, if we take a look at this, okay, remembering back to your Q's, okay, 21 going into 8769, okay, you looked at 21 and you try to divide that into 8. Did that work? Can't do it. So we had to take the 21 and divide it into the 87. How many times does 21 go into 87, Caitlin? 4 times. So we put our 4 up here. Okay, once we threw our 4 up there, everyone, what did we do? Okay, let's slow it down a little bit here. We took the 21, multiply it 4 times the 21. Now how we did that is we went 4 times 1, which gave me 4, then 4 times 2, which gave me the value of 8. Okay, 4 times 1, 4, 4 times 2, we got 8. And then what did we do then, Amberlyn? Okay, we subtracted. So we subtracted. So when we subtract here, we have 8 minus 8, which is 0. And then 7 and 4, we get a value of 11. We get 11 there? What should we get? 3. How'd you get 3?
Because 7 minus 4 is 3.
Oh. So if I subtract 8 minus 8, I get 0 there. But the 7 and 4, I don't add those?
No.
I still subtract them. Okay, so I get a value of 11. No, not 11. He said the answer was 3. All right. Sure it's not 11?
I'm sure.
Okay. What do we do next? What do we do next, Connor? We subtract it down. We got the 3. What's the next thing we do? Oh, yeah. Carson, my bad.
Bring 6 down.
My bad. There's a C. We bring the 6 down. My bad. We bring the 6 down. And we go through the exact same process. How many times does 21 go into 36? That's what, Callista? 1 time. And then what we do? 1 times the 1, which is 1. 1 times the 2, which is 2. And then we subtract. And we come up with what? How much? Okay, so we use 3 minus 2, which is 1. Not sure it's not 17? It's 15, right? 6 plus 1 is 7. Isn't 6 plus 1 7? Or are we supposed to subtract them? My bad. So we have a value of 5. Okay, last step, Mike, is do what?
Drop down to 9.
Drop down to 9. How many times does 21 go into 159? Well, if I don't know that, what is a good little indicator of finding out how many times 21 go into 159? What did we do? 2 into 15. So we saw how many times 2 went into 15. Okay, and that would give us a starting point at least. 2 goes into 15 7 times. So then I can multiply to make sure. Let's see, 7, 114. Then we subtract down, and we get what? 12. Sure it's not 92 or 106? 12. What do we do with the 12? Seth, what do we do with the 12?
You have to put remainder, so divide by 21.
So we have, that's our remainder. So we wrote that as a fraction of 12 over 21, which is a reducible fraction if we wanted to. 417 over, we can take 3 out of top and bottom, so we have 4/7 as a solution. So over here, we want to follow the same method of madness. Okay, and once again, the thing that Alex told us here was, a little indicator was how many times does 2 go into 15. That's going to be the key idea that we have over here. Because now we're taking x minus 2 into 3x cubed plus 5x squared minus 7x plus 9. Okay, I want to see how many times this x goes into 3x cubed. Which would be what, Phoebe? 3. How many times does 3 or x go into 3x cubed? Say 3, what else do we need to add with that? X squared. If I take 3x cubed and divide by x, this gives me one of my x's, they moved to Texas, so we come down to 3x squared. So we have 3x squared. 4, then we multiply it and subtract. So go ahead, multiply this to both of our terms. So we have the 3 going into the 3 times the x and 3 times the negative 2. 3x squared times the negative 2. And then subtract. Should get a 3x cubed and a minus 6x squared. 3 times, just like we did the 4 times the 2, 4 times the 1, we have the 3x squared times the x and times the negative 2. We follow the same process we just did over to the left. Okay, when we deal with, what's our next step? What do we get down here? Grayson, what do you get?
11x squared.
11x squared. Sure it's not 1x squared? How many came up to 1x squared?
Nope. No, negative x.
Nobody gave us negative 1x squared?
Oh, well, I got a negative x squared.
Negative x squared? Negative x squared? Raise your hand if it's got negative x squared. Get a little higher. Get a little higher, please. It's okay. It's okay. Negative x squared. If you got negative x squared there, put your hand up, please. Get negative x squared there. No, get it up there. Get it up there. Come on, people. Own up to it. Negative x squared. There we go. Thank you very much. If you say your answer is negative x squared, what you have just proved to me is that 87 minus 84 is actually 11.
Huh?
You just proved to me that 87 minus 84, you guys all looked at me like I'm an old person, which I am. And I said that's a value of 11. Well, if you threw this down here and said, well, let's see, this is negative x squared, because 3x squared minus that, I subtract that out, those cancel out. But 5x squared minus 6x squared is negative 1x squared. You just proved to me that 87 minus 84 is equal to 11. Because all we did over here was subtract the 2 8s, but we added the 7 4. When you say this is negative x squared here, you've subtracted this, but you've added these two together. You need to make sure that you get your parentheses in there. So this negative has to go to both of our terms, which gives me a plus 6x squared. So we have a plus 11x squared.
Huh. Cool.
Next step here, we drop down our 6. So we're going to drop down our negative 7x. And then we go through the same process. How many times does x go into 11x squared? How many times does x go into 11x squared? Comes down to what, Ian?
11x.
11x. Go ahead and multiply out. And then subtract down. The 11x squareds cancel out for you. We multiplied by it. We multiplied by the x and then by the 2. Just like over here, we multiplied the 4 times the 2 and the 4 times the 1. We multiplied by both of our values. We multiplied this by both of our values. Our next line down. What's our next line down then, Jacob?
I think there's 15x.
15x, because we need to make sure we subtract. So that means this is negative here, and this turns into a positive here. So we have 15x. If you say that's negative 29x, you're still telling me 87 minus 84 is equal to 11. Then how many times does x go? We can drop down our 9. How many times does x go into 15x? Multiply it out, then find your remainder, and put your remainder on over what we divided by. How many times x go into 15x, person? How many times x go into 15x? 15 times. So we have 15 times x, which is 15x. 15 times negative 2, which is negative 30. Make sure we subtract, which changes both of these signs. So our remainder comes down to what, Cade Mullen?
39.
Oh, thank you. 87 minus 84 is equal to 3. You guys continue to reinforce that with me. I appreciate it. There we go. 21. So we have now 21 plus 21 over x minus 2. Okay, so when we divide out our polynomials, what we come out to? Well, once again, though, there's a lot of, yeah?
How'd you get a negative 9 down
It should be.
Oh, it should be 39. Okay, my bad. I don't know how do I. Oh, that's part of an arrow there. My bad, kid. I apologize.
Nice job.
My arrow looks like a negative there. So we have 39. So this would be 39 over x minus 2. Bless you. Yeah.
Isn't the same thing with synthetic division if you don't have like an exponent, if there's like a gap to set as 0?
Yeah. Okay. So once again, a lot of room for little mistakes throughout this. A lot of room for little mistakes throughout this. So once again, we have humans who want to try to make it easier. The unfortunate thing when we have long division, we we can't clickety-clack polynomials into a calculator and do long division. So we want to make life easier on ourselves. So the synthetic division that we do is very similar to the synthetic substitution. Because if we take a look here, what happened as we went from left to right on the radio dial here? We eliminated term after term after term. And this term that we put up here always was the coefficient of what we had here. So we eliminated these terms from left to right. So all we're going to worry about with synthetic subdivision is, once again, just our coefficients. So if we look at our coefficients here, the value of 3, 5, -7, and 9. This was a given here. Okay, if this is x, 1x, my coefficient here was going to be my coefficient up here. So I don't really worry about the x in front here. What determined our next coefficient in our solution was multiplying the 3 times the -2 to give me -6. And then we subtracted to get to 11. This 11 was my next coefficient. 11 times the -22 gives us our -11. 11 times -2 gives us -22. We subtracted, that gave me 15, which gave me my next coefficient. So what determined my next coefficient was when I did my subtraction here, I got my next coefficient. So all we're going to worry about here is putting a -2 out in front. My first coefficient is a value of 3, which is the first coefficient in my solution. We multiplied 3 times -2 to get -6. Well, I could take the 3 times the -2 just like in synthetic substitution to get -6. But we had to remember to subtract, which changed our sign. Now, if we add down, I get a value of 11. This 11 here is the same as this 11 over here, which is the same as this 11 that's up here in my solution. This 11 we multiplied by -2 to get -22. So if I multiply this 11 by -2, I get -22. But we had to remember to subtract, so 87 minus 84 wasn't a value of 11, so I had to change that sign. So we got a value of 15 here, which is this 15 here, which is this 15 here. How did I get my remainder here? I took the 15 times the -2 to give me -30. But we had to remember to change our sign, which gave us a value of 39. This here is our remainder. This is my constant, this is my x term, this is my x squared term. So we have 3x squared plus 11x plus 15 plus 39 over the x minus 2. Now, the only pain that we have here is every time I had to remember to change my sign. What can we do to manipulate what I have here so I don't have to remember to change that sign every time? Anna?
So you flip the -2 to a +2.
If we change that to a positive, then we can add down. So if we take a look at this sign right here and make it a positive, now I don't have to remember to change that sign. I can just multiply, add down, multiply, add down, multiply, add down. Okay, what I want you to try for your homework for tonight, just the first one here. Do the first one. Okay, other than that, no other homework. Say bye, Mr. Watkins.
Bye, Mr. Watkins.
Have a good day. Yeah.
You could.
Use synthetic division to solve the next problem.